Hello and welcome back to Säkerhetspodcasten live from SecT. Well, almost live anyway.
Almost live. Broadcasts.
Exactly, broadcasting, not streaming. That was an important point made yesterday, I think.
Yeah.
I'm sitting here with Jesper Larsson and Hudson Trammell. No, Trammell Hudson.
Trammell Hudson.
Oh, got that reversed.
Yep.
It works in both ways.
So we just listened to a really amazing talk. What was it about?
So the talk was on my research about building hardware implants for board management controllers, BMCs. That was inspired by the Bloomberg story, the big hack from last year.
Right.
Yep.
And I was trying to figure out what is the technical feasibility of these sort of implants without recognizing that we don't know whether or not the story happened.
Right.
But technically, they're totally feasible.
Yeah, correct. But I think your research was really good because you actually visited the whole supply chain. What was that about? Was it on your holiday, or was like, no, I'm going to do this. I'm going to go to China and have a look. Or why did you do that?
Well, I had a wonderful opportunity to tour a bunch of PCB manufacturing as part of a friend of mine was running a tour through these factories for some startups in Silicon Valley so they could see what's involved in making a physical product. And I was invited to tag along and really jumped at the opportunity.
Of course. Nice friend to have, right?
Yes.
It looked really cool.
That was actually a very fascinating part of your talk, I thought, because it gave me an insight that I never had before. Like
yeah, right?
How does the manufacturing actually happen? It's very fascinating stuff.
Yeah, and it's interesting how much of it is concentrated in the Shenzhen area.
Yeah.
So the ones that I was able to photograph were some of the small manufacturing. I did have the opportunity to tour some much larger ones, but they had
no photos.
But one of them had moved to 100% X-ray of the boards coming out for certain high assurance customers.
Yeah.
Oh, right.
And they also had,
as an effect of this article, or just as quality assurance?
They ramped it from sampling to 100%, I think, as a result of the article.
Yeah, okay, of course.
And specifically looking for implants at that point. So
but
rather than just checking for the connections that are in place and all that kind of stuff.
Right, right. And it was fairly common for high reliability parts, if you're building aircraft or spacecraft parts, to X-ray them all.
Right.
But doing it for computer products was mostly just to verify that the manufacturing processes were,
up to par.
That the solder joints looked good, and so on.
Because that's like in the aviation industry and in the oil rig industry, you X-ray a lot of your welds to see that you don't have cracks in anything because it's really high pressure and so forth. But here it makes sense just to see that you're getting what you get. You showed a really nice slide about the fake RS-232 chip. That was pretty cool when they X-rayed, or when they, what do you call it?
Decapsulated.
Decapsulated it.
Yes.
It's like completely different,
yes,
but looks exactly the same on the surface.
And so there's I didn't really go into it in the talk, but there's several different types of counterfeits that people are concerned about. There's the ones that I did mention with the salvaged parts. They're the ones where some parts are made on what's called a ghost shift, where
like sort of, we're going home now, but let's make 1,000 more anyway.
Exactly.
The same product. Just
right. And then there's these other ones which are work-alike, where and then they have them packaged to look like the same chip, but inside is a completely different process. And from a security perspective, that's actually the scariest one.
Yeah.
Because who knows what other functionality
could be hidden.
Yeah.
Exactly, right.
Oh, that's really crazy. We had an episode about this where we discussed this thing in detail. And the only thing you have made it absolutely clear for everyone in the audience and everyone on the internet now that this is feasible, right? This could be done. But the amount of effort put into doing this is it's so massive, right? You need to intercept, if you're going to do it at scale, I would say, you need to go into the manufacturing plant and everything. So, but since everyone denies this, why was it there? What was the article? Why did it appear? What do you guys think? Why did the Bloomberg article appear?
Well, I'm not sure that any intelligence agency would want to do it at scale.
Right?
Yeah,
I think
like one or maybe 10.
Right. I think they would want to target a very small number of customers. It helps a whole lot for concealment if for containment, if you're only going after one. Otherwise, anyone who buys a Supermicro board could potentially find this sort of thing.
You're exposing yourself way too much.
Exactly. So there's, as I pointed out, the targeted access operations lets them tailor it to a single customer.
Yeah. Okay. Okay.
And that makes a lot more sense, as you mentioned as well. Like, so intercepting something that's going to a specific customer.
Then it's not a supply chain attack, though. Then you just short ship it and then put your implant in, and then.
But that's more feasible.
I would say so.
Well, it's supply chain from the perspective of the customer.
Yeah. Okay. It's true.
It's just not in the manufacturing process.
Exactly. And as I point out, Supermicro was very clear in their letter that all of their protections are on the manufacturing process.
Right.
That once it leaves their factory,
they don't have any.
It's hard for them to control.
Right.
Sure.
It makes sense. So do we think that this actually occurred, or do we think, as my opinion, was this a short in the stock market for Supermicro?
I really tried to avoid speculating about any of the sort of the motivations for why the story appeared, when it appeared, and so on. It seems to me that that they had been working on it for a really long time. That in the article, Bloomberg mentions that they had been talking to sources going back almost to the 2015-2016 timeframe. Right. So it had been a multi-year story, and I don't know what was involved in their timing decision.
It's because everyone that was named in the story has denied it.
There's one guy,
Apple
right?
And Amazon and
do you mean that way? Yeah.
Don't you find it strange that they haven't retracted the story?
I find it very strange that they haven't retracted or provided more detail.
Yeah.
That it seems that if they have made statements that they are confident in their sourcing. And that the editors are confident in the anonymous sources, and typically in a news organization, the editors will meet with or know who the anonymous sources are.
Yeah, right. Yeah.
It's not that the reporters can't just say, "Oh, I talked to some guy and he told me this." The editors will say,
and it has to be like fact checked and reference checked, because who knows how what it is called, the SPI looks like. If you get a schematics of something, how could you as a journalist source the truth out of that? I don't know. You need to have references
maybe
or help.
In a certain way, maybe Bloomberg is trying to save face by not retracting and standing by their claims, and it
could be one
we
case.
We can't tell you our sources, so you're just going to have to take our word for it.
But the argument is solid. I think it's really sound that since this is an ongoing, you can actually see that it's a lot of work behind it, and then it sort of makes sense that they've been working on it for a long time. So, I don't think that legitimizes the whole thing in itself, but still, it's so there is something there, and I'm getting scared.
There must be. Obviously, we don't know the full story, as you mentioned, but. It's certainly feasible, and there's probably a grain of truth or a grain of rice.
Yes, I think there's a rice grain-sized
exactly.
Truth in there. And my feeling is that it very well might have been a TAO type thing.
Yeah.
I would not be surprised if there are lots of these sort of TAO implants out there, and they're going to get harder and harder to find.
Yeah.
That again, with a zero budget sort of capability, you can still produce quite a bit of interesting implants, and the NSA Playset group has been making a lot of recreations of things out of the Ant catalog with basically hobbyist budget.
Right.
And people are now bundling all sorts of electronics into USB cables that are, again, being done by hobbyists with equipment at home. It's
the latest one was the Apple the charger, Thunderbolt charger.
Yeah. And if you tear apart a Thunderbolt cable, did you know that there are CPUs in the cables in both ends?
I had no idea.
That they have firmware. And in fact, if you plug a cable in, sometimes it'll tell you, your device will ask you to please...
unlock to use the...
Well, with it wants to update the firmware in the cable, but it can only update the local end. But they can negotiate with the other end and say, oh, this end is running a different version from the other end.
Oh
please,
my God.
Please turn the cable around.
I didn't know about this.
So that it can update the other end as well.
Oh, that's crazy.
That's insane.
Yeah, and Moore's Law has given us just microscopic CPUs.
Yeah, you showed it in your slide as well. This Cortex, the ARM Cortex processor is like really...
The size of 2 transistors in a 65-bit deal. It's incredible how much Moore's Law has meant in terms of transistor density.
Yeah.
Yeah, and that means obviously it's going to be almost impossible to detect.
Yeah, and like you guys said, like this will be feasible because it's why not, right?
Yeah, but just going back to the Bloomberg story, because I can't quite remember, but they mentioned that the implant was laminated between the PCBs in that story.
So in the story, they mentioned that their sources had found a number of implants. I don't remember the specific number. One of which was the signal coupling capacitor, or signal conditioning coupler, the size of a grain of rice. And then an additional implant was the one laminated inside the PCB. And it is relatively, I wouldn't say common, but it's occasionally you will find embedded passives in PCBs. It's a very expensive process to have it manufactured that way. But it is, if you go to a PCB house, that is something that they will offer to do for you.
Yeah, but that also means that in that case, it would have to be part of the manufacturing process where the implants take place.
So this is where the cover story completely breaks down because it's obvious when it happened. Now, I've also for the Hack in the Box talk where I was bypassing boot card, I did build a small proof of concept that was 0.6 millimeters thick and would fit underneath the flash chip. So you could desolder the flash chip.
Yeah, and put it. Oh, that's nice.
And that was, unless you were really looking for it.
Yeah, you wouldn't be able to see it.
And this would fit in a laptop with the cover closed.
This is really cool stuff.
So that again, zero budget sort of attack.
Yeah.
But the fact that we can fit an FPGA and a small flash memory and a voltage regulator.
Yeah.
In this microscopic size.
Yeah.
That's crazy.
And going back to what Joe Fitzpatrick pointed out, no one knows what's supposed to be in their hardware anyway.
Right.
So if you open your laptop and there's a riser card underneath your flash chip, maybe
yeah,
it should
right.
be there, right?
Oh, this is scary stuff.
But so I mean, this is only going to get
so
worse,
we need
I suppose you could say.
Open hardware for everyone. Period.
It helps.
Yeah.
It does mean that. That motivated customers could validate what they have. But again, in a TAO sort of thing, it would be very hard to tell, how many do you need to sample to determine if you're being targeted.
Yeah.
Right, and obviously you only need one from an attacker's point of view.
One wonderful thing from an attacker's point of view on the BMC is once you have code execution on one, they typically share a common VLAN or a common network segment between all the BMCs. So horizontal movement
of
becomes
course.
very easy.
Yeah. So everyone listening to this, you should throw out your computer, buy a RISC-V, and open hardware for the win.
Open hardware, and then get the capability of analyzing all your hardware on a microscopic level.
Imagining changing computers every other year, that would be terrible. So not again.
Yeah, I mean, just being able to actually verify, even if you have the specs, like this is exactly how it's supposed to be. Actually looking through it and verifying that nothing is added or removed. That's
right, and doing that on the hardware level is difficult. On the software level, we perhaps have some ability to do it. I'm a big fan of hardware roots of trust and what's called remote attestation, where the system is able to cryptographically sign something saying this is the the firmware and the kernel and the initRD and the configuration that is actually running on the machine, which potentially gives you the ability to detect if something has been modified along the way.
If not, it's like incorporated in the CPU or somewhere where it's
exactly.
So then you sort of fails.
Right.
But I know what you mean. Like with what is this called, TPM and what's the, now my brain is fried.
Already.
It doesn't matter. Oh yeah, carry on.
Yeah, I mean, but this is a very, very hard problem to solve, I think, because you can usually go one step further or put your implant somewhere else or move to software or firmware or
both or all of them.
Yeah.
Right. Although if the root of trust is well designed and well secured, an attacker who modifies the firmware would be detected in the attestation phase.
Yeah.
That the idea is that you don't necessarily care what has been run afterwards, as long as you can prove which, the hash of it.
Yeah, what part was manipulated, and sort of directly get a reference or a warning that, hey, this is not how it's supposed to be.
Right. And so there are a few examples of this in use. For instance, Chromebooks will attest to Google the version of Coreboot and the Linux kernel that they have loaded before you log into Google. And Google can say, this is a modified Chromebook. Maybe you shouldn't trust it.
Right.
Through that remote attestation.
That's cool.
And
That's cool.
I think we need to have this sort of capability across all of the systems.
Yeah.
There's a neat project from Molvad called System Transparency,
Yeah.
where they want their servers to be able to attest to their to you, the user, that it has not been tampered with.
Yeah.
And I think this sort of mutual remote attestation
It's really
gives
nice
us a
blog
potential
post.
future.
Really nice, yeah.
Yeah, I mean that's a good way to go. I mean, if we can get there.
Yeah.
But then again, there's firmware everywhere.
There really is.
Yeah.
So it's not going to be easy, but hopefully we can get closer anyway.
Hopefully. With talks like this, shedding light on it, I think it's a really good step in the right direction. And Molvad as well, presenting this system transparency stuff is really good.
Yeah, definitely.
So
it'll be interesting to see if anything else comes with the Bloomberg article.
Yep.
I would like a follow-up at some point.
that would be really awesome to read.
Perhaps next year at SecT we'll have 2 years on.
Yeah.
What do we know?
We'll keep going until something
Pops
someone
out.
says something. Yeah. All right. Do you have anything else to add?
I think we're good. I think it was really nice meeting you and really nice listening to you talk. Really good.
Yeah.
Well, thank you for having me on the podcast.
Thank you very much. And we'll see you guys again just in a little bit.
Yes.
Have a good time.